summer test still happening. Honestly, we're gonna break.
All right, let's formalize our findings a little bit here. Okay, I think everybody's pretty much done with this little investigation. So, what did we come up with for corresponding angles? Some? Yeah, same position, just on the other line, right? Okay, how about same side interior, or consecutive interior? We'll also hear this one called. Like,
same side.
They're on the same side, but then on the. Wait, what do you mean opposite angle?
Like, times 45. The one that P on.
Okay, yeah. So that's what we talked about down here. I guess we can throw those up here as well then.
Same one.
Right. So same side on the inside of the parallel lines, and then these ones add to 180. Right. So I guess we can go ahead and do number 3 up here as well. What was the relationship between the corresponding angles? They're the same, right? They're equal or congruent. So we can say they have equal measures, or the angles are congruent. How about alternate interior?
They have the same angle on opposite sides, and they're.
Yeah, so they're on opposite sides on the inside of the parallel lines. And then they are equal / congruent as well, right? Then how about the last one, alternate exterior? What were those? Okay.
Opposite sides of the outside of the parallel lines.
Yeah. Opposite sides on the outside of the parallel lines. And then were those equal or add to 180 or what? Equal, right? Okay, so what about the very last part? Okay, so we've got our relationships. Do those equal ones and the ones that add to 180, do those relationships remain the same if I move one of the lines? Are alternate exterior angles still equal? Are corresponding angles still equal? Are consecutive interior angles still supplementary? Yes, right? So these relationships hold no matter how this figure is drawn, right? So this figure, we're assuming we have a pair of parallel lines and then just some line that cuts through both of those. All right? Any questions so far? All right, then let's practice some of these. All right, so on that second note sheet that I gave you, oops, there we go. Bless you. Now on the front side of this, we have a picture where we do not have parallel lines, right? We just have two lines right here, M and N, cut by a transversal. Okay, that's a vocab word that we're going to use here. Whenever we have this line that is, case, toss me a marker. whenever we have a line cutting through two other lines, that is called a transversal. Okay. All right, so just a little vocab word that we will use here. So we're just going to take a couple of minutes and practice recognizing what these relationships would be. Right up here, I mean, we've got our angles labeled and then everything filled in for us in this example. Right? For the first one, interior angles are just the angles on the inside. Right? Exterior angles are the angles on the outside. And then we can get a little bit more specific. Okay? The alternate interior angle pairs, we could say, would be, 3 and 5 would be an alternate interior angle pair, or 4 and 6. Then the consecutive interior angles, okay, or we call them same side interior as well. Those pairs would be 3 and 6, or 4 and 5. Alternate exterior, we could say are 1 and 7, or 2 and 8. And then we have 4 pairs of corresponding angles. 1 and 5, 2 and 6, 3 and 7, 4 and 8. Right? So in our diagram down here, okay, let's just take a minute and see if we can come up with the name of the relationship for each of these. So 10 and 16. Right, so I guess we can do the first one together, right? There's a lot going on in this diagram, but if we're looking at 10 and 16, I mean, we don't need to look at this half of the diagram, right? We're just looking at where 10 and 16 are. So what's the relationship between those two angles there? Right, so take a minute and try these 4. There, I mean, technically there is. I mean, we could say like 10 and 15 are consecutive exterior. But, I mean, I don't know why we don't really look at those. It's just not in the curriculum. But, I mean, we absolutely could say like 10 and 15 or 9 and 16 are consecutive exterior. So 12 and 13, they're both on the inside, right? They're not in the same position on the other line, right? Like 9 and 13 would be corresponding. But 12 and 13 are both on the inside of those lines.
Oh, I looked at 4 and 8 and 4 and 5. Up to the top of the picture. I was alternating interior for D. 3 and 9. Then next.
Well, so we're looking at this part of the diagram, right, for 3 and 9. So they're both on the inside of these two lines.
So how do you ever know where it's on the exterior? Like that? Not on the interior.
Well, you just have to identify which part of the diagram you're looking at, right? So 3 and 9 are here. They're both on So I'm not worried about line L at all. So they're both on the inside of these two lines, right? It all comes down to just identifying what part of the diagram we look at. Right. So did we get alternate exterior, corresponding, consecutive interior, and then alternate interior for our relationships here? Questions on those? Okay, so this all comes down to identifying what part of the diagram we're looking at, right? Like for C, okay, if I'm looking at 12 and 13, they're both over here on line Q. So I can ignore line P. Right? Then I just look to see, well, they're both on the same side of the transversal, and they're on the inside of the two other lines. So same side, inside, it's consecutive interior. Okay. So the first three down here, identifying the transversal connecting each pair of angles, may actually help us better see these relationships, right? So identifying the transversal connecting 9 and 13. Okay, well, 9 and 13 are over here. The transversal that they're on is Q. Okay, line Q is the line that both of those are on. So if I'm trying to identify that relationship, I'm just looking at line Q, ignoring line P. Right. The transversal is the line that goes through the other two lines. And so the transversal connecting angles 9 and 13 would be line Q. That's the line that both of those angles are on. Right? So to answer this question, right, we would just say line Q. Okay, but if I wanted to identify that relationship then, and if I cover this up, what would the relationship between 9 and 13 be? Corresponding, right? They're in the exact same position, just on the other line. So even though the question doesn't ask us to do this, we can still say these are corresponding. So how about number 2? What's the transversal connecting 5 and 14? Line L. So that means I can cover up the top half of the diagram, right? So what would the relationship between 5 and 14 be? I guess this is the one that we didn't. These would be consecutive exterior, right? They're on the same side of our transversal on the outside, right? But that we didn't say that that was one of the relationships. We can still write it down though. Consecutive exterior. How about 4 and 6? What is the transversal connecting them? P, right? So I can cover up this half of the diagram and just look at what's the relationship between 4 and 6 now. Alternate interior, right? They're on opposite sides of the transversal, and they're both on the inside of the two parallel lines. Okay. Questions on these? All right. Why don't we go ahead and flip over to the back then? I don't think we need to do a bunch more practice with just identifying the name. What's that?
5.
6 and 14. So what? We can cover up this half, right? So what would the relationship between 6 and 14 be here? Corresponding, right? They're in the same position, just on the other line. But in this case, remember, these two lines aren't parallel, so our property of our corresponding angles being equal wouldn't hold here. But we would still say that these are corresponding angles. All right. So on the back then, okay, we're just using these ideas to actually find measures of angles. Okay, so if we look at this first example, is there more space on your paper? Space on the other side. Oh yeah, I did put space on there. Alright, so in this example, the only thing we're given is that the measure of angle 2 is 75 degrees. Okay, from that, we can come up with the measures of the other 7 angles in this diagram. Right? So what would the measure of angle 1 have to be here? 105, right? Because those are a linear pair. So they would add to 180. Okay, so that linear pair, vertical angles, those things are going to creep back in here as well. How about angle 3? What would that be? 105. We could say these are a linear pair, or these are vertical. How about angle 4? 75. Now, what if we jump down here? Right? What would the measure of angle 5 have to be? 5. Right, now remember, these, we can only do this if we know these lines are parallel. Okay? I guess I should also talk about this notation here. Since I've got these little triangles here, these skinny little triangles on these 2 lines, that's our notation in a diagram to show that lines are parallel. Okay? If we have the same number of little, sometimes they'll show up as triangles, sometimes they'll just be arrows. Okay? So if we have the same number of little triangles or arrows on 2 lines in a diagram, that tells me they're parallel. Okay? So if we finish this out, angle 6 would be 5, angle 7, 5, and angle 8, 75. Okay, so pretty straightforward, right? If we have, excuse me, if we have a pair of parallel lines, there's only 2 different angle measures throughout the whole thing. So down here, in this first exercise, okay, we're only given 1 angle measure, but we're told, okay, if you notice these little arrows, I've got 1 set of arrows here telling me these 2 lines are parallel, and then there's 2 arrows on each of these lines. That tells me that these 2 are parallel. Okay, so that's the notation. So just given 1 measurement, told angle 3 is 102. Just from that, we can come up with the other 15 measurements in this diagram. Right? So, let's do that real quick here. Okay, they only ask us for a few specific ones. Okay, but I mean, it might actually be easier just to fill in the whole thing and then answer the questions. Right? If we know angle 3 is 102, what would angle 2 be? 78. And then from there, the rest of the angles in this diagram will either be 102 or 78, right? Plus 102, 78. Two, 78. Okay, and then we could go and answer each of the individual questions here. Okay. I do want to look real quick at this last one, okay? Because in this last one, we just have 1 pair of parallel lines. Lines P and Q here are not parallel. So we're given 2 pieces of information. And I'm told the measure of angle 9 is 80, and then I'm told the measure of angle 5 is 68. So here, what we have to look at the top as its own separate diagram, and then the bottom as its own separate diagram. Because we're saying here are 2 parallel lines, they're cut by 1 transversal up here. So these 8 angles will share those relationships. And then down here we have a separate non-parallel transversal. So these 8 angles down here will share those relationships. Okay? So we have about a minute.